vertical translations, we're just going to shift up, right? So the way I would have explained this usually to us is if it's not attached to the X, then we're just going to shift up and down in the positive direction. So if it's a plus C, you go up. If it's minus C, you go down. Okay. Any questions? I think we know that. Yeah, easy. So for example, if you've got f of x, which is the black curve, if you've got a plus c, and this c is greater than 0, so therefore you're going up. And if it's minus c, which means c is less than 0, you're going to go down. So this works the same even for like trig curves. So if you've got y equals sine x plus c, I guess, you understand you got y equals sine x, which is a normal graph, plus c is the graph of y equals sine x shifted up c units. All right. For these questions like this, if the graph of the function y equals x squared plus 7x plus 1 is translated 4 units down, you just get this whole function and you take away 4. So it'll look like this here. Y equals x squared plus 7x plus 1, you take away 4. And that would be your new function, of course. Okay, so I think we get these, so I don't need to really do this. Sketch the graph, state the relationship of this to this. State a domain, range, sketch, all right, easy. Obviously, you know that this is shifted down to domain and range. Well, whatever the domain range of the original one was, if you're going to minus 2, then you're gonna keep your domain the same, but your range has changed. Your range is no longer at y cannot equal to 0. Your range is y cannot equal to -2. So it'll look like this because you're shifting it down to, right? So your orange curve, it had a asymptote here, but as you bring it down, your new asymptote is going to be at -2, which is here. Okay, so let me know if I'm going too fast. So vertical translation, tick. Translations are easy. Horizontal translation. So this is the one I usually would have said. It's attached to the x. So if you've got a plus b with a parabola, then you've got to go in the opposite direction. So that means if it's a plus b, you're going to go to the left. If it's a minus b, you go to the right. And that works the same for all of them. Log, absolute values, cubics, exponentials. Ooh, exponentials. Exponentials attached to the x. I don't think this will be moving left. Wait. Yes, it does move left. Sorry. No, exponentials move left. This one. 1 on x plus b hyperbolas. Yep. So we call this a horizontal translation. For horizontal translation, shifting the opposite direction from sine and beta. Understand why this happens, we can change it to make x a subject. That's okay. If you ever want to see what they are, just do x and y intercepts. It's better than making x a subject. Make x equals 0, you'll find your y value. Make y equals 0, therefore you're solving for x. And you'll obviously get x equals -5, which means your x intercepts at -5, so you understand the whole cubic's shifted to the left. -5. Okay. Same thing. What is the relationship between log x plus 3 and log x? Well, log x is your normal log curves. X plus 3 means move the whole thing to the left 3. So usually you have an asymptote at 0 for logs, but your new asymptote is now at -3. Am I going too fast? No, keeping up. So translations, easy. Vertical and horizontal translation. So translations, easy. It's what we know. So y, I just think of a basic parabola. Y equals x squared plus c, go up and down, same direction. Now y equals x plus c squared, go left and right, opposite direction. So translation is pretty much what we know it as from like year, I don't know, maybe year 10, year 11, year 12 now. Dilations. You've also seen this. It's just I guess no one really used this particular word before, maybe as such. So a dilation stretches or compresses a function, changing its size and shape. So for example, a dilation, let's call it stretches or squeezes. These are the words I usually use, but anyway, stretches or squeezes. So a case that you would have used before would have been y equals 2x squared. I usually would have said, look, don't worry about it, it doesn't do much to it. So just draw the parabola out. And that's exactly right. That is your parabola. But the idea with the 2x squared is that because it's multiplied by 2, it's going to get there a lot faster. So for example, if you had to draw both of them, you would have to draw y equals 2x squared there, and then obviously y equals x squared there. If it's half, so if it's slower, then it's going to go even more fast. So this would be like a y equals half x squared. So your dilations are multiplied in front. And then f of x, any function. Of course, I just said that if it's greater than 1, it gets there faster, so it shoots faster. If it's between 0 and 1, you can't say less than 1 because less than 1 means negatives as well. With negatives, we know just flip it upside down. But if it's between 0 and 1, then it makes it slower, like this. So. And then again, same thing for exponentials, for everything. You guys get the idea. Okay, so vertical dilation would be the one that's multiplied by f of x. So y equals k f of x, like the one that we were just doing now. This dilates the curve vertically along the y-axis by a scale factor of k. K is greater than 1, the graph is stretched or expanded. If it's between 0 and 1, the graph is shrunk or compressed, or like I just said, squeezed. A vertical dilation changes the y values of the function. Cool. So the y values of the function are changing. So dilated vertically by a factor of 3, that means 3x squared. Describe how the function, this is related to the function of this. It's obviously divided by 2 or multiplied by half. So it's dilated vertically by half. Right, it's been compressed vertically by half. Okay. Any questions? No. I think we will soon do some of these questions here because they. That should be fine. We can do that. Horizontal dilations of functions, these are attached to your x's instead of to your whole function. So again, just like this 2 was not attached to the x because x is squared. For it to be a horizontal dilation, it's got to be attached to my x, so it's got to look like this. Okay, so horizontal dilation attached to the x, 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 not outside of the x cubed, x squared, in front of the exponential, in front of the quartic, in front of the hyperbola, in front of the absolute value. So notice that with horizontal dilations, the higher the value of A, the more the graph is compressed along the x-axis from left to right. This is inverse variations, and the scale factor for horizontal dilations is actually 1 on A. So 1 on N. This is because horizontal dilations affect the x values of the function. To see this, we can change the subject to x, for example. So if I again made x the subject, you can see that it's a third of cube root y. So when you're trying to draw your x's, your horizontal dilations are 1 on the scale factor of a. So with your horizontal dilations, horizontally by 1 on a. So if you've got y equals f of x, there it is, the black curve. Y equals f of ax, so the a is attached to the x, stretches the curve horizontally along the x-axis by a scale factor of 1 on a. That means if a was greater than 1, the graph is compressed, so the opposite of the above, and if a is between 0 and 1, the graph is going to become stretched. If you want to see why that happens, imagine a number greater than 1, so let's just say 2. Because you know the scale factor is 1 on a, that becomes 1 on 2. And we know from above, we say if it was half, half usually meant to compress or squeeze. If you think of a number between 0 to 1, so let's now say half for a, 1 over a half is 2. 2 was when the graph was actually stretched out. So it works the opposite way, but that's how I remember it. So 1 on a, greater than 1, well, it's not so much that it's greater than 1, it's that you're going to get a number that is, this number is going to become half or like a third or a quarter or a fifth or whatever it is, which means it will become compressed or squeezed. And then if you choose any number between here into here, this will give you a number greater than 1, so 2, 3, 5, 10, 20. So therefore those ones are usually stretched. And looks something like this. Okay. Yeah, we're going to come and do these shortly. Yep, we need to know this negative x. Horizontal dilations. Combinations of transformations. I think we can already know what we've got to do when there's a combination, but I can, or rather, just do the questions instead of the examples. And then just want to see if I'm missing anything. So the problem with this topic is just that it's very convoluted. There's a lot of things that sound very similar or would do very similar things, but they don't. And that's why I just want to make sure we can combine transformations. Again, I feel like we should be able to do that. It wouldn't be too hard for us, but I'll go slowly together and just see if I'm missing anything other than the application questions. Equations and inequalities. No, that's easy. Yep. I think we're good. That was pretty much the hardest bit. Now it's just good questions. Okay, let's go. So let's sketch the graph of that. That's not a problem. So let me pick some questions from here. We'll do them. Find the equation transformation. That's easy. Yep, let's do 11 and 12. The graph shows y equals f of x. Sketch the graph of y equals f of x minus 1. So that's just a translation down 1, or you're going to shift this whole function down 1. So instead of it being at 1, it's now at 0. Instead of being at 2, yep. Any questions there? Easy. And then obviously plus 2, you shift it up to, shift it up to, shift it up to, shift it up to, and then draw the same thing again. Easy stuff. Question 12. Show that 3x plus 1 on x equals to 1 on x plus 3. Anyone have any ideas of how to do that for A?
You can separate the fraction.
Perfect. Well done, Alec. Separate it. Look, if you ever get stuck with LHS and trying to get to the RHS, there's nothing stopping you saying, hey, what's RHS? RHS is 1 on x plus 3. Oh yeah, let me do common denominator. Oh yeah, that looks the same as the left-hand side. Just be aware, a lot of students get stuck on some questions like this in the HSC because they feel like they've always got to do LHS and RHS. You could have done RHS to LHS. What function is this?
Hyperbola.
Shifted up and 3, right? That's a hyperbola that's been shifted up 3. Here's your original hyperbola. We're shifting up 3. Instead of your horizontal asymptote there, it's now at 3. But this vertical asymptote stays the same. And that's it. If you want to work out what number this is, as always, just make y equal to 0, solve, and you should get negative a third. Any questions? Okay, that's the ones I wanted to do. The point P lies on the function. Find the corresponding image point. Just make sure. So if I was looking for 2 and 5, so horizontal translation of B equals to 1. So we should be able to horizontal translation, so 1 left and 1. It's positive 1, and we're going to subtract and go the opposite way. Yep. That's what it is. Okay. The first one I just want to see the next one as well. Minus 2 of what I've done here. Perfect. Okay. So these are the ones that I'm really worried about. So these ones here, I feel like we will eventually get, or we already do get really well. So it's not so much the styles of questions you probably want to do. It's more these styles of questions. The point P, 2 and 5 lies on the function y equals f of x. So for C, think of it like this. I mean, whatever, just pick any function, 2 and 5. So let's just say x is 2, y is 5, somewhere there. Right? It doesn't really matter. Find the corresponding point of P given a horizontal translation with B equals to 1. Okay, so if it's a horizontal translation, we know we're going left and right. And we know we're doing left and right in the opposite direction. We know that the y value will not change, so this will always be on this line. Oops. Will always be on that line, so it will be here somewhere, or here, and you get the idea. If you're already at 2 and 5, you're moving a horizontal translation of with b equals to 1. That means you're moving this whole thing to the left 1 unit. So all it's going to be for your point P, it's going to shift right here. It's going to be at 1 and then 5. So P would be 1, 5. And just make sure. Yeah, perfect. Do we have any questions about that? Makes sense? All right, D. The point, again, let me just draw something up real quick. The point on the graph of y equals f of x minus 2 is the image of point P on y equals f of x. Find the coordinates of P. So what's the difference between C and D? What's the difference in questions from C compared to D?
The -2 is attached to the x.
The -2 is attached to the x. Well, so was this, wasn't it? Because if it's a horizontal translation, isn't this technically f of x minus 1?
Mm-hmm.
Sorry, f of x plus 1. Sorry, not minus 1, plus 1. F of x plus 1, so we're going to move to the left one.
Mm-hmm.
So they're actually pretty similar, and I wanted to show you that. Like, they look very different. I mean, this one's like b equals to 1, and they're actually very similar. It's just worded differently, obviously. But the biggest difference between the two is the first one, C, is actually asking you to find the new image, whereas D is asking you to find the original image, what it would have been from your original function. So you've got to go backwards. Okay, so here, f of x plus 1 in the opposite direction. Here you're going backwards. So what happens is, instead of, see how we minus 1 because we're going in the opposite direction? Okay, so here, now, here, the point Q and 3, -4 on the graph of this. So you would have had an original function. Let's call this our original. I just want to draw it up so we really get this. So that's the original. P would have been somewhere, we don't know. But we know when we shifted this whole thing to the right 2 units. You guys agree with that? We're going to go to the right 2 units. So my new graph becomes this. Tried my best there. We get that? 2 units to the right. The point Q is 3, -4. Point Q is 3. Let's just say, for argument's sake, we'll go there. That's 3, -4. There it is. We've got to go back this way. So you don't plus 2. You don't plus 2. What are you actually meant to do in this case? You're going to go to the left now that you realize. You're obviously going to -2. So P would have the same y coordinate but your p-value, your x-value, sorry, is 1. Do you guys really get that? Because I know it's not taught like that at school. I mean, look at the way you guys get taught. Yeah, all this crap. This, which no one in the world that actually understands math would ever do. Do you guys get it the way I've said it? So Steph, I know you've done this, and I was trying to go through it with you before, but you probably have learned it in a different way. Do you get it the way I'm trying to show it now? And do you feel like it makes more sense this way? Or maybe just the way you've learned it makes more sense? What do you feel? Steph?
Yeah.
Is this way easier? Did you pretty much know how to answer D before I did anything, let's say?
Well, I remember using a formula. So my teacher gave us a formula, and I just go off that, like, yeah.
Yeah.
So I'll try and like put the numbers where they are in like the formula.
So you're pretty much saying you didn't understand what you were doing. You were just doing it because there was a formula given to you. Yeah.
Yeah, I just understood. Yeah, I did it that way.
Yeah, that's fine. That's fine. And do you feel like the way I just did it now? So I said, okay, the point Q, is somewhere here on this new graph, and we've got an original graph, which obviously would have been somewhere here, whatever. I mean, I'm just doing the stuff and then just trying to apply it more visually and make you actually understand what you're doing and why you might be adding 2 here compared to here where we actually subtracted 1. Do you feel like it makes more sense?
Yeah, well, she did some visual stuff as well, but I just what I remember is doing it from the formula, which wasn't bad.
Yeah. Look, the formulas are here, but I haven't seen many students actually remember this stuff. So the idea is, if it's horizontal translation and you're going backwards, then it's x plus 2.
Yeah.
This one, for C, it's just different. That's the problem. But anyways, I think this makes more sense. You guys got to make a decision with your teachers and.
Yeah. All right.
All good then. Let's do another one. And plus, if you don't remember the formulas, well, that's kind of a waste. Whereas I feel like I don't see why it's so hard to. I don't see you forgetting this after what I've done here, because I think you guys already understand. It's a movement to the right 2 units when it's like this. So it's very easier to do it graphically than it is to do it via formulas. But anyways, so that's that one. Maybe we should do one more. Those ones are easy. Oh, okay. Yeah, these ones are all easy. But I mean, why not? Let's have a look at number 12. The point is the image of a point on y equals f of x after it has been translated 4 units to the left. Find the original point. Well, again, so it's saying that you would have had something, whatever. I usually just like to draw these. The point P is the image of a point after it has been translated 4 units to the left. So after you move this 4 units to the left, and then obviously straight away, you already know what you're going to do. But anyways, P is 3 and negative 2. X is 3, negative 2, somewhere there. You know that your other value has to be 4 units to the right. So let's call it Q. Q has to be 3 plus 4 units to the right, and then your Y value doesn't change. So Q is pretty much 7 and negative 2. Okay. Any questions there?
Nope.
Yeah, easy, right? All right. Vertical dilations of functions. All right, let's have a look at this. Describe how, find the scale factor of each. That's easy. The point n lies in the function. Find the image of n on the function y if when this is this. All right, let's see what you're talking about. Find the image of n on the function. Let's see what I would do again for this one. The point n, -1, 8, lies on the function y equals f of x. Now find the image of n on the function y equals k f of x when k equals to 5. All right, k times, so this becomes 5 times the original function. So 5 times the original function. Okay, beautiful. So again, understanding this, f of x, is that x's or y's? So f of x, is that x's or y's?
Why?
Say that again.
Why?
Yes, f of x is y, right? So your new one, y equals k times f of x, you are multiplying the y values by 5. You're multiplying all the y values up by 5. But your x values are not changing, so all that's going to happen is this. Well, we won't go through there. That should have been lower. And it's still going to have the same x-intercept. So it'll look more like this. Okay, you got to ignore that then. So your y values are changing. If you look at it, my x value there, that should have been the same x value, and then that x value is the same. This y value here, the y-intercept became larger. But anyways, there you go. So 8 times 5 will become 40. So that will go all the way up to 40. So your n, very easy, it's just -1 and 40. Steph, that makes sense again, doesn't it? Compared to trying to memorize different formulas for all the different cases. K equals to a half. Well, same thing. Now that you know it's half times the y values, it's just going to be 8 times a half, which is 4. And that should be the answer, right? Yep, -1 and 4, -1 and 40. So like trying to put ratios in and all this stuff. I don't know why you would want to do that. Let's try it again. A function.
I don't think I've ever done it with ratios before, Sam.
Good. I hope they haven't followed this book. Okay. A function y equals f of x is transformed to y equals k of f of x. Again, we know what k does. If the image of point A on the transformed function is -612, find the coordinates of A when k equals 3. Wait, what? If the image of point A on the transformed function is... Oh, okay, yep. So, again, you've got your original function. And then k equals to 3, so you understand it's going to go sharper. Ah, killed it there. That's horrible. All right, let's do it again. Nah, still bad. It's really hard to draw on this like that. Okay, doesn't matter. I think you guys get the idea. If the image of point A, so A would have been, so let's say the transformed on the transform function is -612. So imagine there, -6 and it's 12. I mean, it's so easy to see it like this. You know that that would have tripled in value to get to up here. So of course, what would it have originally been? Alex, you want to tell me the answer for what this would have been? A?
Oh, so it's been tripled?
Yeah.
So
It was
would it be 4?
Yeah, right? -6,4. Simple stuff, right?
Yeah.
When you can see it graphically, like the way I'm showing, I'm trying to really cut off all the jargon. Really understand your graphs, you understand what's happening, then piece of cake. B, you know, this becomes this, and then this, and then this, and this. Oh, what a beautiful mess. All right, we're going to keep going because I think you guys are doing well. Have I lost anyone? All right, that's good. Horizontal dilation. So again, we'll have a look at what's happening for each of these ones here. Horizontal dilation, don't forget they're attached to your X. Okay. Make sure 3, 0. Okay. The points P and Q lie on the function y equals f of x. So again, the points P, -3 and 4, let's just go there. And Q, 9 and 0. Lie on the function y equals f of x. Find the coordinates of the images of P and Q for the function y equals f of ax when a equals to 3. So we understand what's going to happen this time. Again, look at it. It's doing this. That's saying for every x value, replace the x for a 3x. Right? Your original one was this. For every x value, replace that by 3x. So when you solve it and you try to make it for y, x in terms of y, you understand the scale factor is actually 1 on a, or 1 on 3 in this case. Yep. So what we're going to do, we've got for Q, is we're at 9 and 0. So therefore Q is going to become a third of 9 and 0 for the x values. So x values. So that becomes 3 and 0. Whereas P will become a third of -3, which is -1 and 0. And double I, if you've got A is a fifth, that becomes 1 over a fifth, which is 5. So your x values are going to multiply by 5. So therefore, did I write P -3, -1 and 4? The y value shouldn't have changed. I don't know what I did there. Sorry. Times it by 5. So then that becomes -15 and 4 for P, and for Q should be 45 and 0. Check that. I'm sure it's right. -1 and 4. -1 and 4, 15 and 4, yep, 45 and 0. All right, easy. Any questions? All right, let's have a look at the next one. When the function is transformed to this, the coordinates of the image n now becomes 16, -5. Okay, so again, same thing. You know what you would have done. Obviously, you would have multiplied it. So in this case, you're going to go back and divide it. But Let's just do it together so we understand this. So again, you're going to have your normal graph, and then you're going to have your transform graph, which would be a little bit more. So A is A. Yep. So if it's A is 4 for this, what does it do? It makes it. So put it like this. For A equals to 4 because it's a quarter, right? Anyways, your something from up to your red line, I should have made that into red, becomes x is 16 and negative 5. So let's just say there. So that one is 16 and negative 5. You want to work out what it was before it was transformed. Well, again, the way we did the transformations, obviously, were very straightforward. We would have got our original and we would have multiplied it by a third. So this time you're going to get your original. Sorry, you're going to get your 16, your new one, 16 and negative 5. And you're going to divide this by a quarter. So your scale factor is a quarter. You're going to shrink it so they will look like back to where it was. So instead of being at 16, this value probably will go somewhere here, which is 4 and negative 5. Might get shrunk down there somewhere. Oh no, sorry. It actually would increase, wouldn't it? Yes.
Yeah, it would.
Yeah, it would increase. So it would actually go over here somewhere, sorry. So 16 divided by a quarter should become 16 times 4, which is what, 64 and negative 5? And same thing with this guy. It's A is a half, so you're going to divide it by 2, which becomes 8. So this one should be 8 and negative 5. I think we get that. I think we get that. 64 and 8 and negative 5. All right. I'm happy with that. Combinations of transformations. There's really no dramas here. Do one bit at a time. We should be pretty good with this. So let's have a look at some examples. I feel like if you where the equation of the transformation is 2x when the function is by the scale factor and translate 5 units 1 to the left. In which order were the transformations done? Do you guys know how the transformations would be done to something like this? Do you know what would have happened first from x cubed, I guess, to get to 2x plus 5 all cubed? Or well, not really.
Oh, sorry, so which one are we looking at, sorry?
So like B. Well,
Okay.
let's start with A. Let's start with A. Because order is important. Like if you're going to go from y equals x squared to get to 4x squared plus 3, you got to work out like what's the order that was done. So it's saying here, when the function y equals x squared is translated 3 units up and then vertically dilated by scale factor 4, the equation of the transform functions y equals 4x squared plus 3. Find the order in which the transformations were done. Well, of course, what would have been done first? Would you have translated it 3 units up and then dilated it by 4?
No.
No. Of course, if you translate it up 3, then that becomes x squared plus 3, and then timesing it by 4 will give you 4 bracket x squared plus 3, which is not this. You would have first done a vertical dilation of 4, then you would have translated it up 3 units. So that would be the order, like this. You would have done vertical translation 3 units up, and then a vertical translation by scale factor. Oh, they wrote it wrong.
Yeah.
Oh, this is not the equation. Oh, of course. Try the other way around. This way. A vertical dilation by scale factor of 4. There it is. And then translate 3 units up. There it is. 4x squared plus 3. Okay. When the function y equals x cubed is horizontally dilated by a scale factor of half, horizontally dilation, so that means it's attached to the x by half, scale factor of half. So what does k equal to if the scale factor is a half for horizontal?
2.
Yeah, that's 2. And then translated 5 units horizontally to the left, that means plus 5. Okay. In which order were the transformations done this time? Well, let's have a look. If you were just to do the horizontal dilation of the scale factor 2, you're going to get 2x cubed, right? 2x all cubed. And then if you're going to do a plus 5, then you're going to, yeah, it's going to look like that, right? So horizontal translation 5 units to the left will give y equals 2 bracket and then x plus 5. Because you're moving the x's, which is not 2x plus 5 all cubed. If you first moved it 5 units to the left, so x plus 5, then you did your horizontal dilation, which is only attached to the x, then you actually get what you wanted, 2x plus 5 cubed. Do we get the difference between the two? Do we get how that becomes x plus 5 in brackets?
Yep.
Yeah, nice. All right, and C. The equation of the transform function y equals ln 3 bracket x take away 2. So log and then 3, which is a dilation horizontally, x take away 2, which is a translation horizontally to the right. When the function y is horizontally dilated by a scale factor of a third, translated 2 units to the right. In which order were the transformations done? Again, think about it. Let's just say you decided to say, hey, let's translate it 2 units to the right. Therefore, you would write log of x minus 2, right? From log x becomes log x minus 2. And then dilate it. So then you'll multiply by 3, which I think looks exactly like what we wanted. If you did it the other way around, if you did a dilation first, you would write log 3x, and then you're moving the x value. Hold on. If I said, whatever, I'm just confused myself. If I did a horizontal dilation, I would have 3x, and then plus, and then right to the right would be minus 2. So 3x minus 2, which is not what you want. You want 3 bracket x minus 2. So first you will do your translation of 2 units to the right. So that should be log bracket x minus 2, and then the dilation. Yeah, I was thinking that in my head as well, but why the heck? Why did I say that? Why did I say the other way around? X minus 2. And then you're just doing a dilation of x. Well, because the x is changing. Idiot. I was thinking of the other way around. I'm not doing these right in my head. So just don't forget that's attached to the x. So I'm mixing up some of the extension 1 stuff with this. So if I've got a function, what was it? ln x. And f of kx only changes x's. So if I say minus 2, it becomes like this. And then when you're doing kx, even though if k is 3, it does not mean the 3 is going to go in the front. So you're not multiplying the whole x value by 3. Whereas like in extension 1 and stuff, Azra, we will need to do that. So that might confuse it a bit. But anyways, this kx is only attached to the x. So that would look like this. That's what I was doing wrong in my head. So that won't be right. What you want to do is, what do we want? We wanted 3x minus 2. So what you would want to do is first times it by 3. So first you get log of 3x, and then you want to take away 2. Yeah, that's perfect. All right. Did I confuse anyone with the way I was saying it before? Just with that last one? No, that made sense when I fixed it up just now. Oh yeah, pretty much. I just wrote it here. Doing the horizontal dilation first gives this, while doing the horizontal translation first will give it like this. Okay, let's try this one. Okay, find the equation of the function y equals x squared if it is first horizontally dilated with a scale factor of half and then translated 3 units to the right. So first it became this, and then it was 3 units to the right, which means it became this. You guys agree with that? Ah, what am I doing wrong? Oh, to attach to the x, Sam. Why are you being lazy here? Because what am I missing in my head? Oh, I've attached to the x, of course. See, I'm making these mistakes. That's what I was worried about with you guys. That's why I wanted to focus on this. There's a lot of room for error. Well, unless it's just me. Y equals attached to the x. So I like to think of it more like this. Actually, I like to think of it more like this. With y I'm getting it wrong. There we go. F of x squared. So half becomes f of 2x. So it'll look like that. That's better. And then translated 2 units to the right, will become f of 2x. Just the x is subtracted by 3. Yep. So then your y value should become 2, just the x is subtracted by 3. Nope. That. Let me make sure. It's first horizontally dilated with a scale factor of half. So multiply the x value by 2. Yes. Which is correct. Because that's times by 2. 2 squared will get you 4. Then it's translated 3 units to the right. So that means your x value is just translated 3 units to the right. So again, x take away 3. Yeah. Okay. Let's do another one. You pretty much know the section you would want to focus most of your time on, which would be exactly these style of questions. All right, describe the transformations in the correct order to produce the transformed function to this. Okay, what would you do first? First, it's attached to the x, so I would do a translation of 1 to the left, right? A horizontal translation, maybe you want to write. Do you guys agree with that? Sorry, not to the left. Yeah, horizontal translation of 1 to the left is x plus 1.
Yep.
You guys agree with that? Yep. Then it's a horizontal dilation of 2 of scale factor 2. Again, do we agree with that? Maybe we disagree. And then on the vertical translation of 3 down. Anybody agree or disagree with that, I guess? I don't know. Let's have a look. Number 1, horizontal translation, 1 unit left. Number 2, vertical translation of scale factor. 2 vertical. What did I do there? Oh man, it's not attached to the x. Enough getting it wrong. Vertical dilation of scale factor 2, of course, it's attached to the y value. Okay, vertical translation 3 units down. Vertical translation 3 units down. That's better. You guys understand what I did wrong there? Horizontal dilation would be half attached to the x. Maybe I've got to keep saying that to myself. Attached to the x or attached to the y. Vertical dilation, not attached to the x, attached to the whole function, so the whole y value. Okay. All right. B. Can we try B without me? And let me see. I'm going to try it on my own. See if we can get the same answer. Maybe I'm just confusing some of you now during this. Maybe you guys already know what you're doing. Let's see if we can get out B. I'm going to try to think about it as well. All right. Let's see. What is x squared? Yeah, that's what I would do. Okay. Anybody have an answer yet?
Yeah.
All right, let's see. This is what I think as well. I think like that. That's what I personally saw. If you didn't, doesn't matter. Maybe you can do it in a different way. I'll double your answer. What I'm thinking is the first thing to do for y equals x squared, is that you would want to, So y equals x squared has to become y equals 2x squared. 2x squared. And it's going to become y equals 2 bracket x is going to be shifted. I'm going to multiply that by 3. And then we're going to shift it up 1. So pretty much attached to the x is a horizontal dilation. So horizontal dilation, scale factor of half. Then we're going to shift our x's -3, which means we're going to go horizontal translation, +3. Then we're going to go up. So this is multiplied by your x's, which is a vertical dilation of scale factor 3, and then +1 would be a vertical translation +1. Who agrees and disagrees? Because I could be totally wrong.
Well, I did the vertical dilation like second.
Dilation first. Vertical
No, not
dilation.
first.
Well, tell me your steps. Just tell me.
Well, I had horizontal dilation and then vertical.
Horizontal dilation, then vertical dilation.
Yeah, then horizontal translation and vertical translation.
So if you said, okay, so you're saying horizontal did you do your first step as like what I did, or not really? Not like that. You just left it as it is.
I left it.
Okay, so if you did a horizontal dilation, you would have done a horizontal dilation of 2.
Scale factor half.
Yep. So you would have had y equals x squared, which means now y equals x squared, which means now horizontal attached to your x's. So it would look like this. Yep. And then vertical dilation.
Yeah.
Vertical dilation times by 3. Okay. So like this.
Yeah.
And a horizontal translation of what?
6 units right.
Yeah, see, that's the problem. The 6 units right, it's attached to the x. So what you're actually writing is this. 2 bracket x take away 6. Aren't you? Or am I doing it wrong? All right, we'll find out. We will find out. That looks good. This one called HT, VD, VT. Yeah.
Oh, yeah, that makes sense.
It's got to be done like that. It's because when you're saying that, you're actually attaching it to the x only. So it's not 2x take away 6, it's just to the x component. So your x is changing to x take away 6. And then, so you're close. You're doing what I was just doing. And it's okay. Like we'll get our head around it in a second. All right. Alex, L, Azra, are you guys confused?
Yeah, I did mine how Steph did it, because I thought like we had to do all dilation first, then translation.
Right.
That's what I thought.
Yeah, because I think that's what they told me at school. I'm pretty sure.
Yeah, I remember Miss saying that.
Yeah.
No such thing. No such thing. Don't worry about that. You guys are trying to take shortcuts. Don't worry about those shortcuts. If there was, I would be the one telling you it. It's just we've got to just got to do it slowly, and you got to think about from here. You can see the mistakes I was making. It's the mistake that you're just making now. It's just, is it attached to the x or is it attached to the outside, which means it's attached to the y. And if it's attached to the x, when you're saying horizontal, then you got to put it in the inside. Inside, yeah, inside the x. So that's what you're saying. That's all. HH. Whereas V's are going to be in the outside. But anyways, that's fine. is fun. Oh, maybe there's another possible order. If you notice that is in the form where it's not factorized, so we can do the horizontal translation first, then horizontal dilation. Is that what you did? No, you did not. You said HD and then VD. Right. You guys are saying dilations first and then translation. Yeah, no. That won't work. All right. And then what's C? Let's do C. But I like B. I think we should do another one like B. Hold on. Find the domain and range of this. No, that's easy. That's not the problem. Why would you do it so long? This is like you've done in one line. Anyways. What? Very good. Why would you do this? Oh, crazy. Don't ever do your domain range like that. All right, wait. Yes, let's do like number 4. It's like the king of questions. All right. We'll just do it super slowly as well. We're not gonna rush. You're gonna just do the first one, and then we'll check, and we'll see how we're going. Azra, are you getting this?
Yeah.
Slowly, right? Or you get
Yeah.
this? Yeah, all right. All good. Okay. So describe the transformations from y equals x cubed to x minus 1 cubed plus 7. Take your time, think about what I was just saying. Okay, it's attached to the x. So Steph, the first one, you know it's a translation and not a dilation.
Yeah.
You know it's a horizontal translation plus 1.
Yeah.
And then that would give you x minus 1 cubed.
Yeah.
And then of course,
The vertical translation. Yeah.
and b. Alex, tell me b.
Well, first it's a horizontal dilation.
So like be careful with that, right? If you're going to say a horizontal dilation, remember horizontal attached, just wait, let's get that clear. Attached to the
X.
yes, right? Horizontals are going to be attached to the x. So if you're going to say attached to the x, it'll look like this.
Yeah.
There, that's attached to the x. That's a horizontal dilation, which is not true. This is not attached to the x. This is actually a vertical dilation of positive 4. And then, of course,
Vertical translation. 1 unit down.
beautiful. All right, C. L, do you want to try C?
Is it the same as before? So like the vertical dilation of
Yep.
-5
Yeah.
and translation.
Yeah. All right. I think we've got that one down pat. D. Azra, you want to give it a shot? So again, you're starting at x cubed. How would you get to this bit? What would be your first step? Let's say if it was x plus 7. That should be your first step.
Would it be horizontal translation?
Correct. And then we're going to go in the opposite direction for this one, which is minus 7. And then that would get you this, of course. And then we need to times it by 2 for vertical dilation of positive 2. And voila. And then E, I'll do E, just to do it slowly. So again, you can see you're going to go from a cubic to this, but you can see you can factorize this out, right? So it's going to become 6, 2, bracket, x minus 2, all cubed plus 5. Okay, the first thing that would have happened, so if I said the first thing was x minus 2, cubed, and then I'm going to stuff up because I'm never going to get the 2 in there. Or am I? I'm not, because I want the 2 to be cubed as well. Because I want the 2 to be cubed, that's the first thing I'm going to do. So the first thing is we're going to do oh gosh, 2x cubed, right? All right, yeah, 2x cubed, good. All right, attached to the cubic. Be careful. So that one is attached to the x. What did I say? Horizontal dilation of a half. So that would look like this. Y equals 2x cubed. No. Ugh, it's so tempting to write that. Y equals 2x all cubed. True? Horizontal dilation attached to the x. Okay. All right. Then we're going to move it -2. So we're going to do a horizontal translation of +2. We're getting close. Now you're going to times it by 3. So that's a vertical dilation of 6. And then we've got a vertical translation of 5. Done. You guys need to be able to execute that because I can guarantee this will be in your HSC. This one right here. I just feel it. You're the first year, they're going to do it. They're going to put something like that in there. There's no way they're going to test an easy one. All right. Do you want to try the exact same thing again with F? Just make sure you can get it all out. Don't try to just copy it. Try to really see if you can move it all the way yourself. I'll give you 2 minutes to think about that. Okay. Any questions?
No.
No. Let's move on. All right. Yeah, I feel like once you've got what I just said there, really the others are pretty easy. Sometimes the points. Okay, with domain and range, you've got to know what the graph is. Like here, I know this is a parabola that's been shifted to the left -3, and then it's shifted up 5. Right? So your domain hasn't changed, but your range, the lowest value it can be is 5, and then your range is y is going to be greater than or equal to 5, or from 5 to infinity. So you just got to know what the graphs are. Here, you know the absolute value of any number is 0. The absolute value of any number is going to be positive. So the smallest value of this will ever be 0. 0 times 5 is 0. The smallest value of this whole thing will ever be is -2. So your y values are going to be -2 and greater than -2. And your x values can be anything. Here, it's a hyperbola. So shift it up 1. You know that's already your asymptote. So y cannot equal to 1. And you know your horizontal asymptotes are about the bottom. X cannot be, this bottom bit cannot be 0, which means x cannot equal to 2. You know, that's the way I would be attempting my domain range instead of all that stuff that was taught to you guys. You know, it's described. So what I'm saying is domain range is the same as what we've done in year 11. Don't change that. Easy. Easy, easy. All right. Let's try this one. Given the each function, so given this is y equals f of x, sketch the graph of the transformed function for y equals 3 times f of x minus 1. F of x minus 1 means for all x values, you are shifting this whole graph to the right 1 unit, right? So we're going to shift this whole graph to the right 1 unit. So instead of it being here, it's now here. Instead of it being here, it's now here. Instead of it being here, it's here. And you guys get the idea. Right? So shift the whole graph to the right 1 unit. Times it by 3. What does that do? That multiplies all of your y values by 3. So instead of it being at 1, it's going to now be at 3. Instead of it being at 0.5, it's going to be at 1.5. Instead of it being at, what am I doing? That's really bad. Instead of it being at -1, it's going to be at -3. Really bad graph. Any questions there? Negative f of 2x plus 3. Same thing. You would probably be doing your f of 2x bit first. So what does that do? That does a horizontal dilation of half. So so it's not going to be obvious. It's not a dilation. It's just you're squeezing it, right? So horizontal dilation of half So we're going to squeeze this. The intercepts doesn't change. It's not going to be shifted anywhere. It's squeezing will look like that. Negative. What does a negative do? Negative will, yeah,
Reflects it.
yeah, reflects. It'll look like this. +3, shift the whole thing up 3. So it looks something like this. Obviously, maybe a lot more flatter. Something like that. All right. Any questions there? No, that makes sense as well. All right. You guys know how to draw your cubics and exponentials by now? Like this is more, I mean, year 11 based work than it is year 12. If you feel like you need revision on this, just go ahead and draw it. That's just the cubic shifted to the right to. The dilation bit, you can't really draw that this one here. Obviously, they're giving you grid lines and everything, so you can be a little bit more accurate. With 3 here, you can't really draw that. You can probably draw a little bit more steep, but like, come on, think about all the students. That could have been times by 3, and you wouldn't have told the difference from that and that. So, anyways, in the negative, you're just going to flip it, and then plus 1, you're going to go up 1. So, hopefully these functions are okay. If you feel like you want to go through these functions, let me know now, and I will. Otherwise, we'll just keep moving on. Okay. All right. I think so. Pretty okay. Equations and inequalities. This should be pretty easy. So the graph of the cubic function is shown. Solve graphically. That just means find where it equals to 0. So that's just like 2.5 or something. Solve it for equals to 10. 10, you just find where it is, which looks like it's at 3. Solve both of them algebraically. Well, just bring everything to one side and start cube rooting and dividing. Sorry, first cube rooting and solve for x. It's really easy. There it is, 2.5 and 3. So it wasn't a bad guess. 2.4 and 2.9. And there it is in exact form once you solve. So +5 divide to cube root, add 1. +5 divide to cube root plus 1. The graph shows a number of cases. Use the graph to find the solution to where it equals to 10. Again, you just go across and then 4.8 or something. State the meaning of this solution. Shows the number of n of case of measles over t weeks in a country or region. So it just says that you'll have 10 cases of measles over 4.9 weeks in a country or region, and then solve it algebraically. How do we solve it algebraically? You're trying to solve for t. Actually, let's do that one, because I didn't teach you guys logs and exponentials in year 11. So, David. All right, we're trying to solve for t. Divide by 27. That's the first thing you would do. Then you don't want the t on the top, of course, so you're going to log both sides. So when you log both sides, what do you do to the power? Powers come down. And then, of course, you divide by -0.25. You guys are pros by now doing that? Is anyone? Yeah? Alex, L, Steph, you comfortable with doing all of that? Or not really?
Yeah.
Yeah? Anyone not 100% comfortable? Because if you're not, 100%, I can tell you at least 10 marks to 15 marks of your HSC will require exponential equations. So you've got to get more comfortable with these, and obviously doing that. And you just keep doing it again and again. So just solving basic stuff. Let's find something hard. If there's anything. Okay, the inequalities bit, I completely missed that. For the inequality to solve, it being greater than 2, it's just wherever you find your solution. So let's just say, let's say this one, if I said it at 10, and I found my answer at 2.1, if you want it greater than or equal to 10, it means it must be all the numbers after this. So after 2.1. So x, instead of saying x is equal to 2.1, you just say x must be greater than and equal to 2.1. If it said less than or equal to 20, again you find 20, which is 3, and then you're just going to say, therefore x is less than or equal to 3. And that would always be less than or equal to 20. That makes sense, right? Okay. Simple stuff. What do you know? We're done with this topic. Yeah, you can't. Azra, you can actually solve it algebraically because obviously you've learned how to solve inequalities algebraically. The rest of it, you can only do it with equal signs algebraically. Otherwise, you have to do it graphically, which means they'll give you the graph, so it's very easy to spot. Anyways. That's really easy. I don't know why these are challenge questions. It's so easy. I guess so. Why not? Alright. I'll be right back, but if you guys can get started on question 5, there's really nothing there for me to go through. So apparently it's the hardest challenge question they've got. So we'll just do it, and then maybe next week we'll revise, or maybe next week from the looks of it, I'll actually be able to do trig next week. And then the week after, we'll spend that lesson on revising trig and this quadratics before doing our finishing touches for the advanced course. Just going through everything and revising. So, anyways, get started on this, you guys. I'll be right back.
Is that ax squared or cubed?
I think square.
Thank you.
Okay. What is the equation of the axis of symmetry? That should be easy. X equals negative b on 2a, right? What types of transformations on this function will change the axis of symmetry? Okay. Well, I mean, there's 4 types of transformations, I guess. There's horizontal translations, there's vertical translations, there's horizontal dilations, and then vertical dilations. Which one would actually impact the axis of symmetry? Anyone know?
Would it be a horizontal dilation or?
Horizontal dilation. What does a horizontal dilation do?
It's with the x.
Correct. So for your x values become like 2x, whatever, which means this is getting larger, so horizontal dilation.
Yeah.
Correct. What about a vertical dilation? Well,
I
what if
don't think it would, because
we're in
wouldn't
front
it just
of this? Say it again.
I don't think it would, because wouldn't it just like move it up and down?
Or vertical dilation?
Yeah.
It's not that it's moving it up and down. Vertical dilation actually is it's multiplying by 2 here. But by the time you multiply this by 2 and multiply this by 2, this becomes 2a and 2b.
Oh, okay.
Right? And then when you divide it, what's going to happen anyways? The 2 is going to cancel out. So vertical dilation wouldn't, but vertical dilation doesn't move up and down. Be careful. Translation moves up and down. Vertical dilation, it's more that it gets there faster. It's important that you get that. So imagine this one here. A vertical dilation, you're not moving the whole thing up and down. Even, I know what you meant. It's just, it's important that you get it clear. It's there, it goes there faster.
Yeah.
So if it was at, I mean, that's 0 and 0, but if it was at 1 and you're timesing it by 3, so if the original was like this, your faster one would look like this. Oops. Inside. I think you get the idea. And then slower. Will be like that. But yeah, it's not definitely not being moved. Oh. No. Okay, that's cool. So vertical dilation, definitely no. Horizontal dilation, yes, because it's impacting the x, which means that becomes 2x, which becomes 4. 4a and 2b, so that does. Vertical translation, so going up and down, that's affecting c. So that one's a no, and then obviously a horizontal translation, affecting x, again, yes, it would. All right. Find the equation of the axis of symmetry of the quadratic functions. What are you going to do for each case to find the axis of symmetry? Don't make it too hard. Alex, tell me what you would do if I came up to you in like year 10, year 11, before you learned anything else. How do I find the equation of the axis of symmetry for this? What would you have done?
Oh, I think I would have expanded.
You are correct. That's it. So don't get stuck onto this particular topic, because in an exam there is no topic. It's an exam. So everything's in play. So y equals 2x squared, 2 times the inside times 2 is 4x plus 2. minus 2, this is gone. Obviously, what's the axis of symmetry? Minus b on a minus 4, sorry, on 2 times 2. So 2 times 2, which equals to minus 1. Some of us might know that the axis of symmetry, if already factorized, is the component in the middle, because that must give you your vertex. But you're going to prove it each one if you like. So the axis of symmetry here, it's just x equals 3. Here, it's x equals negative b. Here, x equals to negative b on a. Does that make sense? Challenge question. How? Who knows? All right. Oh, there's more. I didn't see any more. Let's go more. Let's see the third question. Okay, let's try that. We haven't done a circle yet. Again, I'll leave that with you guys to think about, maybe for about 2 or 3 minutes. I will help you out. Should I? Does anyone remember what they need to do with something like this? That's definitely not the way we would like to see circles.
Would you complete the square?
Yeah, you've got to complete the square first. So it's got to look like this. So like, you know, I don't know, x minus h, y minus k. But pretty much you've got to complete the square. Let me know if you don't know what's happening. I'll start you off. But if you feel like you know how to complete the square, then go ahead and try to do that. Transform by vertical translation of 3 units down and a horizontal translation of 5 units right. Find the equation of the transformed circle. Just make sure that the answer doesn't get that one wrong. 8, 2. The answer would be, just let me know if you get it out, x squared minus 6x plus y squared plus 8, apparently. No, no one's got it out yet. Okay, let's see. Steph, what have you got so far?
Yeah, I got. Yeah. That line, that's what I have.
Exactly that line?
Yep.
Yeah, that's good. So 4 plus 9 is 13. 13 take away 12 is 1. So you know what the original circle is. -2, +3. There's the center. It's got a radius of 1. So there it is, radius of 1. It's saying now it's being transformed by vertical translation 3 units down. So this thing's going to go 3 units down. 1, 2, 3. Sorry, what am I doing? 1, 2, 1, 0. It's at 0 now. And obviously, you know, it was at 4. But now it's going to be at 3 units down, so it's going to be at 1. And so on and so on. I think we get that. It goes at 2. All right. And the horizontal translation 5 units to the right. So horizontal, it's been moved 5 units to the right. So 5 units to the right would be here. So my center is what now? My center now is x is 3, y value of 0. My radius is still going to be 1. So now you got to write a new equation with this. So which bit did you not do, Stephanie? Did you not continue it here? Or you just didn't know what to do after this one?
After that, I didn't know what to do.
Yeah, so I would have drawn it and then pretty much started doing my shifts, my movements.
Okay.
And then obviously from there you can go, yep, that's x minus 3 squared plus y squared, because that's 0, equals to 1, and then just finish it off. Bring it all to one side. It looks like that's what they've done in the answers. 9 take away 1 is 8. There it is. All right, let's see if I can get you another one like that. I like this one. I guess we can try that. Number 9. Last few minutes. Go. Try that one out. Function y equals 2 to the power of x is transformed to this. Describe the transformations applied. Just so you can keep it in mind. -3 x take away 2. Just so you know that. Or keep in mind. Keep that in mind. First, you have to do the -3. That's my clue. Try to write down your solutions. And think about it. Okay. Are we done with it or still thinking about it?
I think I'm done, but I
Right.
got stuck in one part.
Let's have a look. I'll check the answers and then you can let me know. Challenge. Okay. Reflection in y-axis. Yeah, you could have done that, or you could have just done a horizontal dilation of scale factor of -1/3. Either one would be fine. But anyways, horizontal translation of 2 units to the left. Yep, that's what we would have done. Then you would have done the dilation of 3, and then you would have done a vertical translation 5 units down. Okay, what bit there did you not get right?
No, I got that.
Oh, you got
But
that.
yeah,
Yes.
I just thought with the horizontal translation.
Horizontal translation. Yep.
Yeah. Because it was all at the top,
Yes.
like I got confused if it was like if it
It's
went in
still
with the
attached. Yeah,
dilation.
it's still attached to the x, so that's still a translation if you're moving it plus or minus. If it's multiplying, then it's a dilation.
Yeah. Okay.
Good job.
Same.
Yeah.
Isn't it like, I thought it was like, if it was like -2, it would go to like the right, wouldn't it?
-2 would go, yeah, 2 units to the right, or it's a horizontal translation, 2 units to the left. Hold on. I see what you're saying. Wait. Horizontal translation, 2 units to the left. 2 units to the right for an exponential. Y is equal to x minus 2. You're going to go horizontal translation, 2 units to the right. Yeah, of course. Why the heck did they write 2 units to the left? I don't know. I have no idea why they wrote 2 units to the left. That would be a mistake there. I didn't pick that up. 2 units to the right. Definitely 2 units to the right. Horizontal translation. So we're shifting it to the right 2 units. Well, and do a quick check. That was the original one. It's going to shift it to the right 2 units. Yeah. Don't worry. I did a mistake. It's definitely not to the left. It's been shifted. As you can see, there's the 1 there. That would usually be there. But now that if you can see that line where it meets the x-axis at 2 has been shifted 2 units to the right. Right there. Can you see that? It's at 2 now. You guys get that? So Alex,
Yep.
good spotting. It's 2, but yeah, we know it's 2 units to the right. Just a typo. It's fine. All right, good work. So yeah, next week, Elle, we'll do trig. We'll pretty much finish that within the lesson, and then the week after we'll revise. Maybe we'll revise some of the probability distributions, as well as